to the function that I'm dealing with. Okay, so here we go. So I'm going to draw. Hey, I got pretty good lines going today, don't I? Okay, ooh, that's a good function. So this is f of x, and let's go from A to B. All right, and we know that the area under this bad boy is the area equals the integral from A to B of f of x dx. They are identical. Remember, I don't want to write that silly limit thingy-dingy. All right, think about this. Let's keep it simple. Remember how we built this thing? It's still built very, very simply. It's built by rectangles, right? It's just rectangles. So let's throw a couple of rules and or properties in here. Rules / properties. First things first. Let's think about what the integral from b to a looks like. What does the integral from b to a of f of x dx look like? All right, now think about this. Remember, when I built this thing up, I know that delta x is equal to b minus a over n, right? Remember, this guy was bigger and this guy was smaller. So I took the bigger minus the smallest. Here's the problem. When I take the integral from b to a, delta x is no longer this. It's a minus b over n, right? That's what delta x is. Because this thing just tells me, it's just telling me how to find delta x, which, by the way, we're not going to have to do, after this section, we're not going to have to do that garbage by hand. We're still going to have to be able to identify it, but we're not going to have to do it by hand. Okay, so let's think about that. What happens if a is smaller and b is larger? Then this delta x becomes negative. Now, parenthetically speaking, let's write this up, just because it's a good thing to have just sort of sitting there. The area is also equal to the limit as n goes to infinity of, what do we say, the sum as I goes from 1 to n of f of x sub I times delta x. They're identical. There's no difference. If delta x is negative, what does it do to this whole answer? It makes it negative, right? So the integral from b to a is equal to negative the integral from a to b of f of x dx. That's a wonderful tool. What that tells me is I can flip these guys anytime I want, but I have to throw a negative in there. Nothing to it, right? Oh, how about this guy? How about the integral from a to a of f of x dx? Well, again, just let the delta x do the heavy lifting for you. If I'm taking the integral from a to a, intuitively speaking, just from an area standpoint, if I'm taking the integral from a to a, then how much area is under the curve from a to a? Well, your intuition may say 0. And guess what? You'd be right, because delta x equals a minus a over n, affectionately known as 0. So this whole guy, this delta x is 0. Anything times a 0 is 0, except we know infinity, because that gives us that wacky L'Hopital's situation. Okay? Okay, cool. Again, if you have questions on this, you're definitely going to want to ask me those, because you don't want to get kind of left behind. Okay, how about this one? How about, let's put this over here. Let's go to the integral from a to b of c dx. Now that looks intimidating, but if you really think about it, let me draw a quick sketch. If I take this guy right here, is just a function, right? It's just f of x. So if I let f of x equals c, if this guy is just c, right? And I go from a to b, then what's the integral? Well, the integral is the area. It's the area under the curve. So tell me, what is the area of that rectangle? Right? How tall is it? This height is f of x, right? It's just c. How big is it? Well, it's b minus a. So this is just going to be c times b minus a. Easy. Nothing to it. How about this? How about the integral from a to b of f of x plus g of x dx? Well, where do integrals come from? They come not only from limits, but from sums as well. So the integral of a sum, if I'm going to find this, I mean, I could write the whole thing up for the proof, but you guys would hate me for it, right? Because I just stick an f of x plus g of x in here, and then I could just bust the whole thing up. Because sum of sums can be broken apart, and limit of sums can be broken apart. So this just becomes the integral of a sum is the sum of the integrals, which is wonderful if you're working with them because a to b of g of x dx. Because if you're working with them, and this thing's, if a sum of two functions, you just got awful nasty, screw it, pull them apart. It's easy. Nothing to it. How about this one? The integral from a to b of a constant times a function dx. Well, again, think about where it comes from, right? If I have the limit as n goes to infinity of the sum as I goes from 1 to n of c times f of x sub I times delta x. Well, remember, from pre-calc, hopefully you remember that I can pull a constant out here. And then from pre-calc, hopefully you were actually from calculus, hopefully you remember that I can pull the constant out in front of the limit. So this guy ends up being the constant times the limit as n goes to infinity. I said I wasn't going to prove any of these, but apparently I lied. From 1 to n of f of x sub I times delta x. Well, we know that this is just the integral, so this is the constant times the integral from a to b of f of x dx. God, math is cool. You know you got to like math, and this is so stupid of me to say. You know you got to like math when you're teaching it by yourself in a classroom with no kids, and it still gives you chills. All right, how about if I take a difference? Let's just change the color of my pen because I'm going to be lazy. If I put a minus here, well, I think I've waved my hands and screamed and yelled enough to say that we know there's no such thing as minus. It's just plus with negatives. A negative acts like a constant, right? So I can just pull that sucker out. So nothing to it. All right, there's a couple other fun rules that I want to talk about. You know what, I'm going to have to no, I don't want to redraw it. I'm being lazy. Let's stick a C right there. Okay? Now, what if I go, here's another property. How about the integral from, well, it's not a property, it's just kind of a fun rule. What if I take the integral from a to c of f of x plus the integral from c to b of f of x? Oops, there needs to be a dx there and a dx there. Well, think about that. If I take the integral from a to c, remember, geometry says that you're allowed to add areas, right? That's just that area right there. Plus the integral from c to b, that's just that area right there. Add them together, and what do you get? You get the whole area from a to b, right? So this is the integral from a to b of f of x dx. Now, just for giggles, let's think about what would happen if that c were outside, okay? Because I always have kids ask me that question. All right, how about if this was a, if this was b, and c was out here, okay? If I take the integral from a to c, then that's going to be all of this, right? However, when I take the integral from c to b, what's going to happen? Well, now I'm going from right to left, which means that this is all going to be minus, right? Per, let's see, where's that property? Per this property right there. So what happens when I subtract out, if I take all the area from a to c and then I subtract out this area in here? Well, guess what I'm left with? I'm left with the integral from a to b. It's bomb-proof. And you know me, I love bomb-proof. Okay? All right. Just 3 more properties, then we'll be done for the day, and I'll leave you guys alone. All right? So let's talk about, how about this guy? How about, these are more, well, they're still properties, so we'll stick them in as properties. All right, properties of the integral. So what happens if, they're very intuitive. These are not going to take a whole lot of proof. If f of x is greater than 0 on the closed interval from a to b, what does that imply about the integral? What do we know about the integral from a to b of f of x dx? If the function lives above the x-axis, always, or on the x-axis from a to b, then what has to be true of the area between the function and the x-axis? Well, it's got to be greater than or equal to 0 as well. All right? Easy peasy. How about if f of x is greater than or equal to g of x on the closed interval from a to b? Well, what do you think the property is going to be? If one function's bigger than another one, right? I mean, if I've got, here's f of x, and here's g of x, here's f of x, and here's g of x from a to b, well, what's that say about their integrals? The integral from a to b of f of x dx has to be what? It's got to be greater than or equal to the integral from a to b of g of x dx. Easy. Okay? And then last but not least, think about this one. This one's kind of fun to think about. This one's not as intuitive. If m is less than or equal to f of x is less than or equal to capital M. So we're think just min-max, right? That's an easy way to think about it. All right, on the integral from a to b. All right, so think about that. Let's draw it over here. It'll be easier. All right, so here's little m, and here's big M. All right, and f of x lives between them from a to b. So let's make this a, and let's make this b. All right, then what has to be true of the integral, right? Because really, the integral is going to represent that area right there. Well, the integral from a to b of f of x dx is going to be less than the box created by m times b minus a, right? This is the box. We know that that area right there, the area of that rectangle, is bigger than the integral, right? So I know that this is going to be less than or equal to b minus a times capital M, because that's the area of that guy, right? And this little box right here is the rectangle. I guess it's not a box, is it? It's a rectangle. As a rectangle created by little m, the area of this little guy right here is b minus a, right? Just the length times the width times m. This big box up here is b minus a times big M. So I know that the integral is wedged between those two areas. So this is b minus a times little m. That's it. Integral is area. That's all that we care about. Integral is area. Integral is area. Integral is area. Did I mention integral was area? All right. So for right now, I'm going to tweak that down the road, but us still being able to think about it in terms of area is a really, really, really important skill. All right. Hey, thanks for your time and attention. I'll see you in class tomorrow, and we'll do a bunch of these. Okay? Have a good day.